The electric vehicle world is about to be turned upside down. BYD, one of the biggest names in EV innovation, has just made an announcement that could change everything. Imagine charging your electric vehicle in just 10 minutes. Sounds impossible, right? Well, BYD is about to make it a reality. CEO Wang Chuanfu has revealed a new generation of all-solid-state batteries that could solve the EV industry's biggest challenges. How does it work? And what does this mean for the future of transportation? Stick around as we uncover the science behind this game-changing technology. So, why is BYD switching to solid-state batteries? Before we dive into that, let's first explore what these batteries are and why they might just change the future of electric vehicles. At the heart of BYD's recent announcement lies the exciting development of all-solid-state batteries, a technology that could significantly change the landscape of electric vehicles. Solid-state batteries are a direct departure from the conventional lithium-ion batteries that have powered the majority of electric vehicles for over a decade. These traditional lithium-ion batteries rely on liquid electrolytes to facilitate the movement of ions between the battery's positive and negative electrodes. While these batteries have been the backbone of the EV industry, they come with several inherent limitations, including safety risks, slower charging times, and reduced lifespans due to degradation over time from repeated charging cycles. In contrast, solid-state batteries utilize a solid electrolyte material rather than a liquid. This design shift addresses many of the problems associated with liquid-based electrolytes, offering several compelling advantages. Solid electrolytes are non-flammable, making them much safer than their liquid counterparts, which are prone to combustion under certain conditions. Additionally, solid-state batteries are more durable, capable of achieving higher energy densities, and can potentially offer longer lifespans. These qualities make solid-state batteries a highly attractive alternative for electric vehicles, offering a host of improvements that could accelerate EV adoption and shape the future of clean transportation. But what's so great about solid-state batteries that made BYD decide to make the switch? Let's dive into the advantages that could completely change the game for electric vehicles. BYD's all-solid-state battery technology promises to deliver a number of significant benefits that could revolutionize the performance of electric vehicles. From faster charging times to enhanced safety and sustainability, these advantages make the transition to electric mobility even more appealing to consumers. And they lay the foundation for a future where electric vehicles are more accessible, practical, and environmentally friendly. One of the most thrilling claims about BYD's new all-solid-state batteries is their ability to achieve a full charge in just 10 minutes. Charging time has long been one of the major pain points for electric vehicle owners, with most current lithium-ion batteries requiring anywhere from 30 minutes to several hours for a full charge, depending on the type of charger and the battery's capacity. The prospect of a 10-minute charge represents a monumental leap forward, bridging the gap between electric and traditional gasoline-powered vehicles when it comes to convenience. For consumers, this fast charging capability could significantly change the EV ownership experience. A 10-minute charging window would allow drivers to quickly recharge their vehicles during short stops at rest areas along highways, while running errands, or during a lunch break, making long-distance travel much more practical. Drivers would no longer need to plan their trips around the availability of fast-charging stations, eliminating one of the most common barriers to EV adoption. The ability to charge an electric vehicle as quickly as it takes to fill up a gas tank would bring unprecedented convenience to drivers, encouraging more people to make the switch from fossil fuel-powered cars to electric vehicles. Another standout advantage of all solid-state batteries is their significantly higher energy density compared to traditional lithium-ion batteries. Energy density refers to the amount of energy that can be stored in a given volume. As the world continues to focus on curbing carbon emissions and fighting climate change, the broader adoption of EVs powered by solid-state batteries could be a pivotal factor in reducing transportation-related emissions. More EVs on the road would help decrease the reliance on fossil fuels, mitigating the environmental impact of personal transportation. The longer lifespan of solid-state batteries would also reduce waste, as fewer batteries would need to be disposed of and replaced over time. This reduction in e-waste and resource consumption could make the entire life cycle of electric vehicles more sustainable, contributing to cleaner and greener transportation on a global scale. Finally, the introduction of solid-state batteries that charge in just 10 minutes could significantly change consumer perceptions about electric vehicles. Until now, Many drivers have viewed EVs as inconvenient, with issues like long charging times, limited range, and uncertainty about charging infrastructure. BYD's innovation has the potential to eliminate these concerns and reshape how people think about electric vehicles. The convenience of fast charging would lead to a more positive ownership experience, helping to shift consumer attitudes toward electric vehicles. As more drivers experience the ease of owning and driving an EV, the market could witness a cultural shift in favor of electric mobility, with more people viewing EVs as viable, desirable options for their transportation needs. This shift in perception would not only benefit BYD, but also boost the credibility and attractiveness of the EV industry as a whole. Material sourcing presents another significant hurdle. Solid-state batteries often require rare or expensive materials like lithium metal anodes, specialized sulfides, or ceramics for their solid electrolytes. Securing stable, ethical, and cost-effective supply chains for these materials at scale is critical. Geopolitical factors and limited global reserves of key minerals could constrain production and drive up costs. Additionally, processing these advanced materials to meet the strict purity and consistency standards required for solid-state batteries adds further complexity and expense to the manufacturing process. Cost remains perhaps the most formidable barrier to widespread adoption. Currently, producing solid-state batteries is substantially more expensive than manufacturing conventional lithium-ion batteries. The novel materials, intricate manufacturing processes, and lower production yields all contribute to this high cost. For solid-state batteries to be commercially viable in mass-market electric vehicles, their price must become competitive with, or ideally lower than, today's mature lithium-ion technology. Achieving this cost parity will demand not only economies of scale, but also breakthroughs in material science, process engineering, and supply chain optimization. It's a steep challenge, though one that parallels the cost reduction journey lithium-ion batteries themselves underwent over the past decade. Beyond scalability and cost, the technology itself needs thorough validation. While BYD's announcement of 10-minute charging is revolutionary, translating laboratory success into reliable, durable, and safe performance in millions of vehicles under diverse real-world conditions requires extensive testing. Long-term cycle life, performance in extreme temperatures, resistance to physical damage, and overall safety protocols need rigorous verification over time. Solid-state batteries are less prone to thermal runaway than liquid electrolyte batteries, but new failure modes specific to solid electrolytes and interfaces could emerge, necessitating comprehensive safety testing and robust battery management systems. The competitive landscape also adds pressure. BYD is not alone in the race to commercialize solid-state batteries. Major players like Toyota, CATL, Samsung, and numerous startups are investing heavily. While BYD aims for production readiness by 2026, others have their own aggressive timelines. Success depends not only on technological achievement, but also on execution speed, manufacturing prowess, and the ability to form strategic partnerships across the supply chain. Delays or technical setbacks by any contender could impact the broader perception and adoption timeline of the technology. Despite these substantial challenges, the potential rewards are immense. Overcoming the hurdles of manufacturing scalability, material sourcing, cost reduction, and rigorous validation would unlock a new era for electric vehicles. The combination of ultra-fast charging, increased range, enhanced safety, longer lifespan, and greater sustainability offered by solid-state batteries addresses the core limitations that have hindered broader EV acceptance. If BYD and its competitors can successfully navigate these obstacles, solid-state technology has the power to truly revolutionize transportation, accelerating the global shift towards cleaner, more efficient electric mobility, and fundamentally changing how we power our vehicles. The road ahead is complex, but the destination promises a transformative leap for the EV industry. BYD's solid-state batteries are truly a game-changer for the EV industry. But with this milestone, what challenges still lie ahead? Let's dive in and find out. BYD's announcement of all solid-state batteries with 10-minute charging times marks a significant breakthrough in the electric vehicle EV industry. However, despite the immense potential these batteries hold, several challenges remain before they can be mass-produced and widely adopted. From manufacturing scalability to material sourcing and cost concerns, there are key hurdles to overcome before solid-state batteries become a mainstream reality. One of the major challenges BYD and other companies face in the EV battery space is manufacturing scalability. Currently, the production processes for solid-state batteries are expensive and complex. Scaling up production to meet the demand for electric vehicles will require substantial investments in new manufacturing technologies and facilities. Solid-state batteries differ from traditional lithium-ion batteries in their internal structure and the materials used, especially in their solid electrolytes. These differences introduce challenges in terms of manufacturing methods, as solid-state batteries require more precise and labor-intensive production processes. To achieve cost-effectiveness, companies must develop more efficient manufacturing techniques and invest in specialized equipment. The success of solid-state battery adoption depends on the ability to scale production efficiently and meet market demand, which could take years of research and investment.